Okay, guys, here's my goal for today's class. I know many of you still do not feel that comfortable with coordinate proofs, right? Because you're not really too sure what to write down, what's enough work, is this statement correct? I get it, I understand that. So today is going to be dedicated to coordinate geometry proofs, making sure we have those down pat. And also, I'm going to introduce a new vocabulary term and a trapezoid as well. So that's the two goals today. Get you guys more comfortable with the coordinate proof and introduce a new part of a trapezoid that you've never heard about before. So on this first one here, I need you to do me one favor. I need you to switch coordinates C and D. So coordinate C is going to be 7, 5, and coordinate D will be 3, 5. All right, if I graph the coordinates I have, it won't go in a clockwise or counterclockwise direction, which is against the rules, as you guys know. So make coordinate C 7, 5 and coordinate D 3, 5 for me. Appreciate it. And go ahead and graph it. All right, so part A, it's kind of squeezed in there. I don't know if you guys see it or not, but we do have a part A, and it is show that this is a trapezoid. So here's a coordinate proof. Also, test Thursday, one coordinate proof, and good news, that's the only proof I put on. Okay, one proof on Thursday's unit test, and it's going to be a coordinate one. No statements, reasons to worry about. How about that, kids? How about that? All right, so we got to show this is a trapezoid. I'm going to turn this over to somebody now. What do you know about a trapezoid? A trapezoid, not isosceles, just a trapezoid. What do you know about a trapezoid? Let me get my numbers out. Thought I had them. All right, you guys know your numbers. Let's go. 12 in the house. Here we go. 12. What do we know about a trapezoid as I find them?
One pair of sides is parallel.
One pair of opposite sides is parallel. So we need to show one pair of opposite sides parallel. And in addition to that, when you do a coordinate proof, yes, you do need to show me the other pair is not parallel. All right, so we're talking about parallel lines here. What formula have we been using this unit shows that two lines are parallel? What formula am I going to need here that's going to show two lines are parallel? Here we go. Let's hear from 10. It's going to show that. You guys just all of a sudden forgot your numbers? No 10 in the house? I'm going to find these numbers. Oh, lucky you guys got them. What's that, Caroline? Atticus, let's go, bud. 10. What formula am I going to need to show two lines are parallel? And you're muted if you're trying to talk. What formula shows that two lines are parallel? All right, let me ask you this. What are the only two formulas we've used so far in a coordinate proof?
The distance formula and some other one to show something. And I know it's not the distance one.
Okay, I'm going to pry this out of you. We use this formula you're trying to figure out to show lines are parallel and to show lines are perpendicular by doing negative reciprocals.
Slope.
There we go. We need the slope formula here, everyone, don't we? So step number 1, you always show me the formula you're using. So we're going to say M for slope, change in Y over change in X. Or, you guys know how I roll when I graph, rise over run if you prefer. All right, step one in a coordinate proof. Show me what formula you're about to use. Here we go. I hear the ding. Go ahead, Radhika.
Do you have to write down both or only the one that you're using?
Only the one you're going to use. Yep, only the one you're going to use. Step two in a coordinate proof, use the formula you just wrote down. Now use it. So we're going to find the slope of all four sides. So let's start with DC, everybody. DC. I got good news. You don't need to use either formula to find the slope of DC. Look on your paper. It is a horizontal line. A horizontal line. So there's no reason to use the formula. We can just remember, and somebody chime in here because I'm not going to call on somebody because I don't know how many of you know this. If you have a horizontal line, what's the slope equal to?
0.
That's 0. The slope is 0 if it's a horizontal line. Perfect. Let's go slope of AB. Hey, good news again. It's also a horizontal line. So we could say the slope of AB, also 0. Oh, DC and AB have the same slope. That must mean something, which I'll ask somebody in a second. But let's find the slope of the other two sides. Let's go AD. Slope of AD. Ooh, you are going to have to do some work for that, so I'll let you do it. Go ahead. I'll ask somebody in a minute. You can do rise over run, or you can do the y coordinates over the x coordinates for the slope of AD. I am going to ask somebody, so grind away here. Calculate it. Up and over how many? Use the coordinates. All right, when you're ready, let me know. Slope of AD, 13. Here we go. Sophia, when you're ready, what was the slope of AD?
2.
2. Positive 2, everyone. Good. Positive 2. And then one more slope, which would be CB. All right, let's talk. CB is a vertical line now. Vertical lines. Anybody remember back from our slope discussions? Slope of a vertical line. Not 0 anymore.
Isn't it like undefined?
There is none. Correct. There is none. Undefined. So the slope of CB is undefined, meaning there is no slope. All right. Much different than 0. All right. So I did the formula in step 1. I used the formula in step 2. Step 3. What did you just learn by using the slope formula now? What did we just learn by using the slope formula? All right. First question I'm going to have. 6. Here we go. Caroline's not here today. Let's go 16. Kyla, here you go. Kyla, we just found DC and AB have the same slopes. What do I know about them then?
They're parallel.
Okay, so here we go. DC parallel to AB because slopes are equal. I'm also keeping in the back of my mind that this has to be a trapezoid. So not only do you have to tell me those two are parallel. Here we go, 20, Radhika. AD and CB have different slopes. So what do we know about them?
They're not parallel.
They're not parallel. And I need to tell you guys that they're not parallel if I'm going to prove a trapezoid. AD not parallel to CB because slopes are not parallel, are not equal. Got to tell me the other pair are not parallel. That eliminates the possibility that it could be a parallelogram. And then finally, all right, perfect. You just wanted a trapezoid. You got it. ABCD is a trapezoid. Because, and now I'm going to open it up to somebody. Give me a nice reason here. Your own reason. Why is it a trapezoid? In your own words. 1-7, Maeve. Why is this a trapezoid?
One pair of parallel sides, and it has one pair of non-parallel sides.
There you go. That's the part I was looking for. I know most of you are going to write one pair of opposite sides parallel, but I also need and the other pair is not. You've got to tell me in your own words the other pair is not parallel.
Could you also just say only one pair of sides is parallel?
That's fine too. That's good semantics right there. Yep.
Would it be fine if I said that it's a trapezoid because it's a quadrilateral with one pair of parallel sides?
With only one pair of parallel sides, because I have a parallelogram that's got one pair of parallel sides. But if you say only, that means the other pair could not be. Because in your reason, Kyla, you're still leaving the possibility that it could still be a parallelogram. And I want to eliminate that possibility. So if you write the word only in there, that's fine. Everyone good here? Coordinate proof? Proving a trapezoid. All right, now I want to show you a special part of a trapezoid you've never heard or seen before. And to do that, let's go to part B. Now I want you to find the midpoints of the non-parallel sides. And so it's going to be midpoint of AD, because remember, we switched the coordinates. So it's going to be the midpoint of AD and the midpoint of side CB. This is how I'm going to introduce this new part to a trapezoid. All right, CB. Let's do CB first. The midpoint of CB. And I want you guys to call that point F for me when we graph it. CB. You don't need the midpoint formula. No need for the midpoint formula. Just look at CB and find the midpoint. And let me know what it is. Here you go. 2. Quincy, what's the midpoint? What's that coordinate for the midpoint of CB?
For CB it would be 7, 3.
7, 3. Yep, you can stop there. 7, 3. Everyone, make sure you graph it. Call it point F. All right, let's go to the other non-parallel side, which is AD. Some of you can probably just look at your diagram, but I do want to remind you. Here you go. Midpoint formula. You're going to add your x's and divide by 2. Remember. And you're going to do the same thing for the y's. If you want to use the formula instead, I know it's pretty easy here to find out what the midpoint is if you graphed it with some detail. We're going to call this point E when we graph it. All right, point E. All right, here you go. What's the midpoint of AD? When you get it, take your time if you don't have it. What do we got? 1, 5 here. Will, what do you got for me, Will, when you get it?
2, 3.
You got it. Everyone go ahead, graph 2, 3, call it point E. All right, let's talk about this new part of a trapezoid that you just found. When you connect the midpoints of the non-parallel sides, when you connect the midpoints of the non-parallel sides, you have formed what we're going to refer to as a mid-segment. Look at these clever mathematicians, kids, huh? When you connect the midpoints, you get a mid-segment. Huh. You connect the midpoints of the non-parallel sides, you end up with a part called the mid-segment. There's also another term for it that you may see in homework. It's also sometimes referred to as a median of the trapezoid. Okay? I like the term mid-segment. But I think on homework tonight, we use the word median. So median of a trapezoid and mid-segment are the same terms. All right, you guys see how it's formed. Why are we going to talk about it, though? Because it's got a couple properties I want you to know, too. All right, and you guys are going to figure out the properties on your own by doing, let's go to part C. Part C. What's the slope of EF? Oh, this should be quick, right, kids? This should be quick. Slope of EF, we just discussed it up above. It's a horizontal line, so what's your slope of EF? Boom, 10. Atticus, what's the slope of EF?
I was still looking for it.
What's there to look for? It's on the graph. We just Graphed E and F, which are the midpoint?
0.
0, because it's a horizontal line, so the slope is 0. Why did we find the slope? I'll tell you in a second when we write down the properties of a midsegment. Now, find the length of these three sides, AB, EF, and CD. And don't start whining, all right? Don't start complaining on me. Oh, we need the distance formula. No, you don't. They're horizontal lines. Just count the suckers, all right? You don't need distance here. Stop the whining. Just find me the lengths. Boom, here we go. 11. Anthony got the lengths of AB.
6,
6. How about EF?
5,
And CD.
4.
There you go. Good job. 6, 5, and 4. All right, by doing part C and D, what did we just show about a midsegment? Well, here comes the theorems for you right now. Here comes the theorems. I don't want you guys to cheat yet, so I'll just cover that up. All right, what did we just learn about a midsegment? So a midsegment of a trapezoid you just figured out 2 facts. 2 facts. So let's go back to part C right now. Go back to part C, where I asked you guys for the slope. All right, I asked you guys for the slope of the midsegment in part C. All right, let me talk to somebody here about it. 2s. Hannah, good morning. What did we find the slope of EF to be, Hannah, in part C?
0.
And didn't we also, in the proof, find that DC and AB were also a slope of 0?
Yeah.
So what do I know about DC, AB, and EF if they all have the same slopes?
They're parallel to each other.
Great job. So there's theorem number 1, is that a midsegment is parallel to the bases, always. Okay, midsegment is parallel to the bases. So if I just go back real quick here, if you guys want a little visual of what I just wrote for that theorem, all 3 here are parallel to each other. All right, second theorem deals with part D. Look at the lengths we found. Let me write the lengths on my trapezoid here. We found 6, 5, and 4. Whew, this is going to be a little bit tougher theorem to get out. Anybody see any relationship between the length of the midsegment and the lengths of the bases? And just don't tell me, it's right in between. It's right in between. All right, because that, let me change the numbers up on you then. Let's say this is 18 and this is 24. How are you going to find the length of the midsegment? Right? There's no number in between there. So 4 and 6 were the bases, and we got a midsegment of 5. Anybody think they can come up with the theorem on how to find the midsegment length if I know the bases? Whoa, look at all the dings here. You guys can just go ahead. I'm not really a big fan of this hand stuff on Google Meet, but
The middle or the mid segment is the distance of the mid segment is the middle of the distances of 18 or of 4 and 6. So if you were to add 18 and 24 and divide it by 2, that would give you the distance of the middle.
okay, so let me put some math vocabulary terms to your reasoning there, Radhika. All right, let's put some math vocabulary terms. Let me go back to my theorems here. So basically, here's what we just said. The length is half And she said when you add the two bases together, when I add two numbers, the result usually is called the sum. So the length is half the sum of the bases. Okay, guys? So a mid-segment's length will always be half of the two bases added together. Nice.
Can I also say average?
Average is a nice word, is a nice mathematical term as well. I love it. Average, good. Anybody else want to chime in before we actually do one? We're going to get a homework problem done too right now. Let's get a homework problem done. So go ahead, go to number 1 on the homework tonight. Oh, look at how clever. Meet trapezoid trap. Oh, that never gets old. Median MQ. See, I used the term median there. Remember, that's the same as mid-segment. They're interchangeable. Mid-segment, median, same thing. Solve for X and Y. I'm going to start with Y first. I'm going to have somebody come up with an equation for Y. We just went over what the mid-segment was equal to. So jot something down on your paper right now so you're ready to give me an answer. Remember, MQ is the mid-segment. We just went over the theorem of what it's equal to. And you guys see where the two bases are. All right, got an equation to solve for Y using the new theorem we just put in. 13, here we go. Sophia, got an equation for me?
12y plus 1 plus 18y plus 6 equals 16y plus 1.
Okay, missing something. Here you go. You got the mid-segment. What you gave me was the mid-segment is equal to the two bases added up.
Put the first part in parentheses and put a half in front of it.
There you go. Good. It's half the sum of the bases. So I can either put a 1/2 in front, or if you guys, maybe some of you guys did this and just divided all of this by 2. Good. Same thing. Okay, same thing. Yep. So does everybody see us applying the mid-segment theorem here? I threw one of these on Thursday as well, the test, a little mid-segment question. All right, so now it's just your algebra ability. Let me clean up what's inside the parenthesis, 30y plus 7. I'm assuming most of you guys are going to distribute the 1/2 next. You could also just multiply both sides by 2 if you wanted to cancel out the 1/2. It's up to you, but I think most of you guys would probably distribute and get 15y plus 3.5. I know this is where the shakes come in with some of you honors kids when you see a decimal in an equation. Oh boy. Move the 15y over. And let's move the 1 over by subtracting it. So 2.5. 2.5. All right, you ready for X? X has nothing to do with the MQ being a mid-segment, nothing to do with it, but it does have everything to do with, hey, this is a trapezoid, so I know TR is parallel to PA. And you could, if you want to, yes, MQ is parallel to the other two as well. All right, I have 3 angle measurements up there, T, P, and A. I'm going to ask somebody, what is the relationship with 2 out of those 3 angles? 2 out of those 3 angles have a special relationship because the lines are parallel. Name the 2 angles that have the relationship. You got it. Come on. Radhika, back to you. What 2 angles have the special relationship? Oh, I stump?
Would it be angle T and P?
Yeah, come on now. T and P, what type of angles are they as far as the parallel lines go?
Alternate interior.
Oh, my heart. My heart. Here's TR. Here's.
Wait, are they supplementary?
Let's try this again. T and I'm not making these congruent. I'm just putting their markings here. I'll do this. There you go. What type of angles are those?
Oh, they're same side. Wait. Yeah, they're same side interior.
There we go. So that makes them what? Congruent or supplementary?
Supplementary.
Whew. All right. You made me nervous. 2x minus 4 plus 7x plus 13 equals $1.80. Now, I don't know if how many of you, if I called on you, we're going to say angle P and angle A are congruent because they're base angles. That's in an isosceles trapezoid, remember. Base angles are only congruent in an isosceles trapezoid, kids. All right, not here. Not here. All right, do your thing. 19x plus 9 equals $1.80. 19x equals 171. And then x equals, oh boy, if I remember from first period 9. There we go. Everyone all right? P and A are not congruent unless it's isosceles, which it's not. Everyone confident? We good? Mid-segment of a trapezoid. All right, we're going to end class today with a proof you're going to do on your own. So go back to number 2 in the notes. And I say you're going to do it on your own because it's really what you feel comfortable, how you feel comfortable doing this proof. A, B, C, D, prove it's a parallelogram. And there's many different ways I could do it. The only thing I'm going to do with you guys is ask two of you guys, how do you prove a parallelogram? Tell me one way to prove a parallelogram. And then you guys are going to pick the way you feel most comfortable and go. Still got plenty of time here. So I think some of you guys are finishing graphing it right now. All right, first question. Tell me one way I could prove it a parallelogram. If I show what, it would be a parallelogram. Show what makes it into a parallelogram. There we go. Emma. If I could show what, Emma, it would be a parallelogram.
2 pairs of parallel sides.
Okay, you can do that. Absolutely. If I did that, I would need slope formula. So if you guys like using slope, do it that way. If you don't like using slope, there's other ways to prove it a parallelogram. What's another way I could show it's a parallelogram instead? 18. Owen, what's another way I could show it instead of showing opposite sides parallel?
1 pair of opposite sides parallel and congruent.
Whoa, you're one of the hardcore ones, huh? Yes, remember the special case? 1 pair congruent and parallel. So you guys would not only need slopes, you would also need distances. So if you guys wanted to get real hardcore on me, you could do that. And then one other way I would think many of you might choose. What's another way I could prove a parallelogram? And this is where I'm going to end it. Sophia, one more way to prove a parallelogram?
Opposite sides congruent.
There you go. And if you guys want to do that, you're going to have to use all distances. I'm not going to force you how to do it on the test. I'm not going to force you and tell you have to do it this way. You do what you're comfortable with. All right, so go ahead. That's how we're going to finish class today. You pick the method you're going to use. Step 1. Step 1. What formula you're going to use or formulas. Step 2, use them. Step 3, what did you learn? And then step 4, why is this bad boy a parallelogram? I'm just going to put up on your screen right now what the slopes and distances turn out to be so you can check them as you go along. All right, there are your slopes and distances depending on what method you're choosing.
And this is a case where you'd be able to just say opposite sides are parallel instead of needing to say like both.
Yep, correct. Yep, that's fine. Yep, because that is true. So depending on what method you guys did, make sure our slopes or distances match up.
And you said we want to keep the distances and they're not break them down, right?
You can, Maeve, you can, but if you do make a mistake, I got to take off for it. So that's why I recommend for a coordinate proof, just leave it.
It should come out to like around 4 steps, right? Or
It should be, yep. Your step 1 should be the formula. Step 2 should be using it. Step 3 is what did you learn by using the formula? Sides are equal, sides are parallel. And then step 4 is your final statement telling me why it's a parallelogram. And we're not signing off early here, so if you have more time, keep going on the coordinate proofs that I assigned for the homework tonight. Because you already did problem 1, that's done. As you guys are working right now, one final thing I got to let you know. On Friday, the day after we take the test, we do start our new unit. And I know a majority of you do not like taking the notes on your Chromebook. So at the front of the high school, in the front entrance of the high school, I put the new packets for Unit 7. So if you have the opportunity and availability to swing by the school front entrance, just ask for an honors geometry packet for Mr. Carlino and they'll give you one. Okay, so Friday we're going to start the new unit. They're there right now at the front entrance if you guys want to swing by if you can and grab a packet for Friday. They'll be there until Friday. So just a heads up there.
Would step number 3 just be saying like AB, like the segment AB is congruent to CD and BC congruent to AD? Is that all you would say?
Because distances are equal. And just let me know why you know they're equal. All right. So it's how do you know they're congruent? Because the distances are equal. Yep. Or they're parallel because slopes are equal.
With number 2 on the homework, I
Uh,
started trying to use.
Go ahead. I just got to pull it. Go ahead.
I started trying to use Pythagorean theorem to prove the distance, so I could prove the legs are the same.
Okay.
Am I able to do that? Am I allowed to do that?
Which is this quadrilateral math?
Yeah. The only thing is that this is the isosceles prove that it's an isosceles trapezoid.
Okay, so you got to prove it a trapezoid first, right?
I did that.
Okay, prove it's a trapezoid like we did in class today, and then now you're doing the legs are equal?
Yeah, I was going to use Pythagorean theorem, but it's kind of just 0 squared equals 0. Like 0 squared equals 0 squared. There's not really a triangle there.
What is it, a vertical line?
Yeah, there's a vertical line and a horizontal line, so I might just end up using distance.
So vertical, if it's a vertical line, Sophia, just count it. You don't need to use anything special if you're going to find the distance of a vertical line. You just count it.
Oh,
And then the diagonal one, you can do Pythag or distance. Yep.
okay.
All right.
Makes it easy.
All right, guys, I'll get you out of here. We only have a minute left, so I'll get you out of here. If you have any questions, hop in after school today. And remember, the new unit packet, we're going to start on Friday, is up at the front entrance of the high school if you get an opportunity to want it. Okay, guys, I'll see you tomorrow when we review for the test. Take care, guys. Good job today.